All right, same hand, module 7. I chose a problem where we're looking for x, y, and z over the 3 formulas. First one is 2x minus 8y plus 2z, which equals -4. The second is 2x minus y minus 2z equals -8. And the third one is -4x plus 3y minus z equals 11. All right, so to do this, we need to work through the process of elimination of the letters themselves. I chose z for this equation. Just the 2's are already lined up for me. Could have done the x's, but 2's are already lined up, and then it just becomes easier after that. So with that, I chose the first two. 1, 2, which is 2x minus 8y plus 2z equals -4, and then 2x minus y minus 2z equals -8. So from here we just add these two together. And actually, because you see here, it's just before the z before this, before 2x minus 9y, it cancels out, equals -12. So this is 4x. 4x. I'm just gonna write it down one more time. 4x minus 9y, -12. Alright, so with that, this creates problem number 4, which we'll use again in a second. I then went with 1 and 3. So 1 equals 2x minus 8y plus 2z equals -4. That's it, -3. 4x plus 3y minus z equals 11. And the problem with this, the z's, which I'm trying to cancel out, don't line up. So the way we do this, I'm going to need 2, so I'm just going to multiply 3 by 2. Let's for this guy, not lose it. Should use colors like you do, but so for the second one, I will write it over. So 2x minus 8y plus 2z is -4, and then 2 times 4x plus 3y minus z equals 11. That'll come down, that becomes -8x plus, that's not right, 2, and that is 6. Yeah, 6y minus, that would cancel each other out, 2z minus 2z equals 22. Let's add this back on top. 2x minus 8y plus 2z equals 4. And again, now we're just adding these together to make problem number 5. This will come out to be -6x plus 14y. Those cancel out. Equals 18. Alright, so now, take problem 4 and problem 5. We're going to do math together, but we need to then, well, we'll get to it. Let's place them together. 4x minus y equals -12, -6x 14, y equals 18. Now, we're going to eliminate the x's, which means we need to change out the coefficients on each other to balance them out. That's why I say so 24 and 24 is what it comes up to, but we will take 6 times this to keep it positive, and then 4 times this to keep it negative. That will end up separating all those. So 6 times 4 is 24x minus 54y equals negative 72. We'll do the same 4 across, so that'd be there, negative 24x, look at that, plus 16, 56y equals 72, right? 36, 72, yeah, 72. Alright, so this gives me a 0 as my answer, with this being 2y. So this tells me y is 0. Okay. So in all of these problems top, y equals 0, leaving the x and the z's to equate to whatever these numbers are. So we can just eliminate that on the process. But to put this back into play, we will actually add this into either one of the 4 or 5s, since we have already eliminated the z's in them, to find the x's. So we'll go with 5 first. Since y is 0, we're just going to eliminate that together. So negative 6x equals 18. X equals negative 3. Now, for this to be true, this should also equal x equals negative 3. So what is the y? So 4x equals negative 12. Well, sure enough, x equals negative 3. Meaning x equals negative 3. Now that we have the x and the y, the z's and all these should add up, or be the same for each of these equations. So if we take the first one, negative 3 times 2 is 6, excuse me, negative 6 minus 0, negative 6 minus 0 is still negative 6, plus 2z. Let's just do that real quick. Negative 6, this is negative 3, yeah, times that, it's negative 6, times 0, plus 2z equals negative 4. Sorry, can't see what I'm writing. Just wrote all that. Hope you heard me. We're going to add 2z equals 2. Z equals 1. So if z is to equal 1, it must be true in all this as well, so real quick. Negative 6 plus 2 is negative 4. Negative 6, still 0. Negative 6 minus 2 is going to be negative 8. Negative 4 times negative 12 is 12, still 0. 12 plus, excuse me, 12 minus 1 is 11. All right. So our answer in an order pair will be x equals negative 3, y equals 0, and z equals 1. Still in my hand.